Let's consider an example dealing with average velocity. So we've got a situation where Google Maps gives you several different routes from Marymount High School to Lebanon Sports Complex. You're going to select a route to take, and then we're going to do some calculations on it. So let's consider the fastest route. So first thing I'm going to do is list out what we know about the fastest route. The time period is 34 minutes and it is 25 miles. So delta T, 34 minutes, and delta X, 25 miles. In part A, we want to calculate the average velocity at which Google anticipates you will travel in meters per second. So then first thing I'm going to do is convert these values over. Minutes. We know that 1 minute is equivalent to 60 seconds. So if we convert that over, we get 2,040 seconds. And then miles, 1 mile is equivalent to 1609 meters. And so we're going to get 40,225 meters. So we want the average velocity on part A. Writing out the equation, V is equal to delta X over delta T. So my delta X value I'm going to replace with the 40,225 meters. The delta T, the 2040 seconds. So dividing those two, that gives us an average velocity of 19.72 meters per second. Now, heading into part B, we've got a little bit of additional information that's given. After 15 minutes of driving, you are on I-71 North passing I-275. Map says that you have 16 miles left to your destination. So if we kind of chart out, we started at MHS and we're ending at Lebanon Sports Complex. We know this total trip is 25 miles. We've gone, well, we don't know how far we've gone. However, we have 16 miles left in the trip. So if we have 16 miles left, we can quickly deduce how far we've traveled. It's just going to be the difference in these two. And that's what we're asked in part B. What distance have you traveled? Well, that delta X, 25 miles, minus 16 miles, tells us that we have gone 9 miles. Now, part C, are you running on schedule? Well, there are some different ways we can address that question. We know we've gone 9 miles, and it also tells us that we've taken 15 minutes to do that. We can figure out, well, at our average speed, how far should we have gone in this 15-minute time period? Another way we can think of it is we've gone 9 miles in 15 minutes. Well, what's that going to give us for an average speed, and how does it compare to what we calculated up in part A? So if I'm going to do that, first thing I'm going to do is convert this 9 miles over. Again, 1 mile, 1609 meters. So that gives us 9 miles is 14,481 meters. So then if we calculate our new, or we should probably say our actual speed, V is equal to delta X over delta T. So it's going to be our delta X, 14,481 meters, over our time, 15 minutes. And again, doing the conversion, 1 minute is 60 seconds. That's going to give us our V actual to be 16.09 meters. per second. Now we can see, comparing the 1609 to the 19.72, we are traveling much slower. And if we're traveling much slower, then we are behind schedule. Part D. On your return drive, you take the fastest route, but there is traffic and it takes you 40 minutes to return to Marymount High School. Calculate your average speed on the return trip. Well, and this was part C. Part D, V is equal to delta X over delta T. So it takes us 40 minutes to be able to travel the whole return trip. Well, the return trip is 25 miles, which is 40,225 meters. And our time, 40 minutes, converted, again, 60 seconds for each minute. That's going to give us an average speed of 16.76 meters per second. So, overall summarizing, anytime on problems, list out what you know. Always identify the equations, plug in numbers, do the relevant conversions that you need to. Okay, sometimes drawing a diagram can also help to be able to organize and see what you know. Ponder physics.